All right, good evening. That volume's a bit boomy, just let me drop that a notch. All right, nice to see you all on this, well, quite pleasant winter evening. So those of you listening at home, I can see quite a few spare seats, so if you feel like coming in and joining us here next week, please be welcome to do so. All right, so I've caught up a bit of my week one duties. What do we have? We have a course forum, Piazza. As my email said, please sign up with your full name, the one that appears on your UNSW transcript or whatever. That doesn't mean you have to show it to fellow students when asking questions. You can post anonymously, but it lets me and the tutors see who you are. And we want this in particular because people often ask questions like, my submission, the auto test didn't work, or something's happening with something I'm doing, and we can actually go and look at your code and save a lot of time and give you a quick, accurate answer. And I'm even trying to come up with tools to do that. So tutors in the forum are showing your code next to your question. And anyway, so it all depends on us knowing who you are when you ask a question in Piazza. So use your full name. There's plenty of parts of the internet where you can be anonymous if that's what amuses you. Right, one thing, course forum, lecture recordings, you have to go via Moodle, but they should be working. Tell me if they're not, because often I don't know. Lecture recording. Survey. So I sent out a survey. I want to know a more accurate idea across the class of who knows what languages, so I sent out a survey. Bad news would be I broke the SQL database before sending out the survey link. The good news is I may not be very smart with SQL, but I did think to write a log file so I can recover everyone's data from who entered data while the database was broken from the log file. But please put in the survey so we know what languages you know. It's not anonymous, so I can get at the end of the course and see, oh, you know, the people who had learned Java beforehand did really badly and figure out why that is, or vice versa, and so on. So I am going to keep your ZID and these things and look at and analyse what happens. If you don't, the survey is optional if you don't want that. Survey course web page. You have a link to Tutes and Labs start next week. Sorry, this is a particularly bad starter session for me. You should have the Tutes and Labs tomorrow, late tomorrow. Failing that, I'll have to spend my Saturday morning doing them, but I don't want that, so I'll try and get them done tomorrow. Next week's Tutes and Lab are pretty easy. I'm going to talk, well, easy-ish. It's a gentle induction. There are still people coming into the course. New Tute Lab tomorrow, won't be on tomorrow. It'll be 9 to 12 Friday. The office staff are trying to get it all set up. So it should open tomorrow, we hope. I'll send out an email and encourage people to swap to it if it suits them, just to try and create some gaps, then other people can swap around and maybe get times that suit them better. And there's some people that want to come into the course. Because there are people who may come into the course, we don't try to do too much in week 2. So don't be disappointed if week 2 student labs aren't that hard. Don't worry, we'll give you plenty to do in later weeks. I've just been talking to a couple of tutors. Sorry, and again, the handbook for this course doesn't really tell you give you a feeling for the course, but in a couple of words, it's practical, not theoretical, and it's coding, and even more coding. So if that's what you want, stay in the course. If it's not, maybe think about changing courses while you still can. Tutors are talking to me about, we're adding, I think, 3 weeks of JavaScript. We're trying to get some guest lectures in who knows JavaScript's better than mine. And we're shuffling the Python and Perl about a bit, and maybe some more Git. So we're trying to improve the content. With this will be I can't tell you exactly what's going to be when and which assignment will do what yet, sorry. So a little bit of uncertainty, but B, it's a better course. The stuff you'll learn is going to improve the course. So there may be the odd teething thing you'll have to forgive. And there was one thing I forgot yesterday, which I want to emphasise not only from this course, but for this school, this degree, this university. We've had problems within CSE with how students treat other students. Specifically, we had a very unpleasant incident. When was it? It must have been last year, where a female student got treated very badly on Facebook by male students, which we were very unhappy about, and we followed up with misconduct proceedings against the male students. But it's not just female students being treated badly. We've seen a number of incidences of this sort of thing. In fact, yesterday I was dealing with a student who was treating me quite unpleasantly. Now, this is, yeah, it's not really a problem for me because I have all the power, so I don't have to worry about what he thinks about me. But it's also an issue, and I'm thinking, geez, this language he's using is completely inappropriate. And if he goes to for a university, and it's not appropriate also if he goes to a job. So he's not going to prosper in a work environment, and if someone asked me for a reference, it would be, do not hire this person. I regularly get, I tell tutors, one of the parts of the deal of tutoring is, if you need a reference for a job, I'll do it. And you'd think that people they'd be phoning up and asking about, what their marks are like, what they're like academically. But what the people calling up about jobs is they're most interested in, do they communicate well? Are they a team player? Will they get on with other people? That's the big thing they always ask about. So here in this university, we deal with other students. We treat them all with respect, with politely. We've hired a set of tutors who'll do just that, whether you're heading for the university medal or your WAM is 49.3. The tutors will treat you with respect and try and help you learn. And I expect the reverse. I expect you treating all the tutors with respect. So I'm not worried about the student who was rude to me. It did occur to me, my God, what's he been saying to the tutors in my course? So, yeah, respect with everyone. This is a learning environment where we appreciate the diversity we have here. And, yeah, I think you've got my point anyway. All right. Let's move to has anyone got questions about that? Anyone got questions about the course generally, admin, that sort of stuff? We're all good? Could be worse then, it's week 1 and there are no major issues. All right, so I'm going to talk about Unix filters again today. But first I have to talk, well, we saw a filter called, it gets called grep. But the version, it has a couple of incarnations and versions, and the one we saw was the best one to use is actually gets called egrep. And you specify a string, well, not exactly a string, and it reads, given no file arguments, it reads from standard input and passes through a subset of lines, the subset of lines that contain the string. But of course, often when we want to have this is a really common thing to want to do. It's an incredibly common thing to want to do. Often, though, it's not just one string we want to match. We want to pass through lines that have got any of several strings. And you start doing this more and more, and you start to realize it's not, you don't just want to specify a set of strings, pass through any lines that contain any of this set of substrings. You need a little language to specify the sets. It's convenient to have a little language to specify the sets. If we go back in history, a few people got this sort of idea and started coming up with half languages, sort of well, they're simple languages to specify sets of strings. But then someone called Ken Thompson, who had a good math undergrad apparently, looked a bit at mathematical theory and came up with a really nice notation for sets of strings. Now he's saying, but wait, didn't you say Ken Thompson invented Unix, the operating system used on every second computer around the world today? Yes, he did. So as well as being the person who got Unix started, he came up with this notation. He's an amazing guy. When I was a PhD student. He came and spent a year at Sydney University, and you used to talk to him at lunchtime, and he wouldn't want to talk about coding. He'd want to talk about astronomy or flying jet aircraft or things like this. It was really quite, yeah. He certainly deserved the Turing Award he got about 10 years ago. All right. So what does his language look like? Oh, I first should say everyone thinks his language is great. It's so caught on that any programming language that you're likely to use will have libraries, at least one library, probably several, that implement his language for sets of strings. His language is called regular expressions. So what does his language look like? All right, by default, a character matches itself. So if you don't know anything else about a character, it just matches itself. So you see the character A, that just means a string with an A in that position. So what's our first special character? Asterisk. Asterisk is our first special character. Now some of you are thinking, I know about asterisks. I've seen it with shells. Various sorts of shells have asterisks as a special character. Sorry, it's different here. You're thinking, how can we have a course where a character has a different meaning in two contexts? Oh, you haven't seen anything yet. It gets so much worse. But asterisk in a regular expression means 0 or more repetition. So P asterisk means 0 P's, 1 P's. So yes, P asterisk it denotes a set. The set includes the empty string, the string of 1P, the string of 2P's, the string of 3P's, and so on. And in fact, it denotes an infinite set. So a string containing 1,000 P's in a row, yes, that's in the set. That's one special character for you. Vertical bar or pipe, that denotes alternation. You're saying, but wait, yesterday wasn't pipe connect standard in to standard output? Yes, it was. So if you're typing a command to the shell, pipe means one thing. If you're typing it to a regular expression, you're using an irregular expression, completely different meaning. Your brain may explode before the end of session. So if I have something like Perl, pipe, we'll say vertical bar, Python or Ruby, that's a notation for a set of 3 strings. What else have we got? Round brackets, parentheses, grouping. The good news here is that's what round brackets have meant since about year 3, isn't it? I'm not sure where you got round brackets. Was it year 3 they teach you round brackets? But still the same thing in a... well, not quite. I guess there's a bit of a complication. But grouping is the big thing with round brackets. What else do we need? There must be something else we need. Oh, how do we remove the meaning of something? We can remove the meaning in regular expressions with a backslash. So if we want a literal asterisk, we put a backslash before an asterisk. What is that sound? All right, I won't pick on the person there. Their mum probably needs to know what the sandwiches were like. Okay, so 5 special characters. Oh, that's not very good. My vertical bar's broken. Round brackets, asterisks, vertical bar, and backslash are all you need for regular expressions in a mathematical sense. You've heard, do you know, for example, in the language C, which constructs you need to write any C program? Do you need if statements? No. You need while statements in C, while statements, assignments, and probably one arithmetic operator. And that's all you need to write any C program. In practical terms, you may find you need a little more than that. Same applies with regular expressions. So let's show you 1 or 2 other useful things which you'll need, including for next week's lab. If you want to say, I want any character here, you can say dot. And that gives you well, if we assume 7-bit ASCII, it gives you 128 possibilities. So dot says a string with any character here. Often you want a limited set of characters, so you can use square brackets for that. So if you want to say a string with a vowel here, lowercase vowel, you can say square brackets A-E-I-O-U. You can put ranges in that to get letters, digits, and in a truly horrendous piece of syntax, you can put square brackets up at to invert the set. And you're saying, but didn't we see up hat or caret with another meaning? Yes, it has 2 meanings within regular expressions alone, let alone the other context you might see it. So this is starting to suggest to us that we have to think very carefully with characters what context they're in and who's going to interpret them. What's reading this string? How's it going to get interpreted? Inside square brackets, other characters actually lose their meaning. That's not crucial, but you'll see that. I think this is I'll peek ahead. Oh no, well, we've got a few more things. We'll start working on some examples. But anchoring matches. If we want to talk about strings starting or ending with a particular string, we can use up at to say anchor to the start and dollar to anchor to the finish. That'll make much more sense once we've seen examples. Okay. Ooh. Repetition. You could do what plus and question mark do. You could denote that with what we've seen already. You can left as an exercise. But plus means one or more repetitions of P, and question mark means 0 or 1 repetitions. Often convenient. In fact, I think in my recollection is I was looking at next week's lab and I was thinking there was an exercise to get exactly right. Question mark was your friend. Let's see some examples. Let's start off with, what do we have to see examples of? So I've said there, egrep says pass-through lines marching, and we know now this is a regular expression, and this could be denoting an infinite set of strings. As it is, I'd say if we assume 128 characters, that's a very narrow view of the world, I know, but that would be that's specifying 128 strings. So that will match so there we go. Nice. What else can we do here? Oh, but that won't match cold. But if I say that, that's combining. Actually, we'll go to a simpler one first. We'll come back to that one. Forget you saw that. So I've noticed people often spell my name with variable numbers of E's. I can match lines with capital A, N, D, R, E, star, W. And it'll match a line that says Andrew and a line that says, yes, it does. And asterisk is 0 or more repetitions, so it even matches the unfortunate there. Those of you who had to deal with users who are very lazy in the way they specify inputs to your programs are thinking, rather I could use this rather than saying if they've said specification X and if they misspell it, there's all sorts of problems. You can use something less exact. But what about this? Oh no. It doesn't match a lowercase Andrew. All right, we already know one way. Oh. There is something, by the way, already a trap I've fallen into. I said asterisk has a special meaning to the shell. So what I've done is actually dangerous. We might come back to that. The shell has been nice to me and hasn't interpreted that asterisk. What does the shell do with asterisks? Anyone know? You should know. You should have had, yep. Yeah, sort of. Yeah, it does a match against file names. So there's a few characters the shell says, it sees them, it tries to match them against file names. So comp 1.5.1's over, and I want to get rid of all my C programs. That will remove all my C programs. I can even find out what programs it would remove. It would remove those programs. Oh, of course, we're in that directory. Okay. I won't remove those programs. So in the current directory, there's nothing. This is sort of interesting. I think this is interesting. You might think the shell is going to say, error, Andrew. No files match this. Or you might think it's going to give me an empty set. It doesn't do either of that. The shell actually knows that maybe I'm trying to pass that asterisk through to another program, and it does something that's a bit risky, but convenient 99% of the time. If it doesn't match, if the asterisk doesn't match any file names, it just leaves it there and passes it through to whatever program you're giving it as argument. That's great until you run this command in a directory that's got a file called Andrew or something like that that does match, and then the command breaks. What do we do about this? All right, it's better when running things on the shell command line if they've got weird characters in them and you don't know exactly what's going to happen, to put single quotes around them and say to the shell, don't interpret this. So much we need to know. All right, so I've used square brackets now, and that will match. Oh no, it won't match that. Uppercase. Oh. Uppercase looks a bit tedious, doesn't it? I can do this though. Bear with me, just stand there and pretend this is something you want to see. Oh wait, this is just seeming too tedious. There must be a better way. Yes. You've got to think this. Whenever you get in this situation, you've got to think, lots of people must be in this situation. There must be a way out of this. In grep's case, there's an option to say ignore case that says, don't worry about case. A very wise thing to use in most situations. We'll see this again and again. Every good programmer, when they're dealing with input in this sort of way, should be asking them a couple of questions. One is, do I care about case? If I don't, ignore it. The next one would be, do I care about white space? If not, ignore it. I don't know how much I do quite a bit of online shopping. And there's nothing more annoying than these sites that insist you put spaces between credit card numbers or don't put spaces between credit card numbers or phone numbers and things like this. And thinking, why? It was just one little thing for the programmer to do, to throw away the white space, and it just all worked. Don't be that programmer. All right. You'll see in other contexts other ways to ignore case. All right. I think I'd better keep moving. There's a few things we've got to show you so you've seen them, to give you clues before next week's student lab. All right. This is enrollment data. All right. With lectures being videoed and things like this, this is synthetic enrollment data. This is not a real student. So was it last year? Maybe it was the year before. I accidentally exposed a SSH key in a lecture, and I covered up really quickly. And I thought, no student can have seen that. Then it occurred with me, the lecture's videoed. They can pause the video and just copy this SSH key. Oh. All right, so the lesson is, Andrew, don't put anything remotely private in lectures. So this is synthetic data. This is actually actual data download we work with in CSC, saying that Rebecca Fang, ZID that, there's no Rebecca, well, there may be a Rebecca Fang, but it's not a ZID, and this is fictitious. Comp 1511, that's her program, her plan, her WAM. 0 means she hasn't done any courses before. Well, hopefully it means that. And her date of birth. Oh, 2009. What? That doesn't seem right. No. I'm a bit worried about that. Oh, 2009-21. Okay, that's all right. All right, so there's about a set of about 10 programs that pretty much fit this Unix filter model, and I've showed you most of them already in last lecture, but I'll show you some more that are great when you've got this sort of data and questions you want to quickly know about. So first question might be, how many students in the enrolments? When do we do this? So this is out of date. There's 10,000 this year. So this file has 7,569 lines. Maybe I just want to look at some of the lines. There are 2 useful programs that fit this filter mold. Typically sit on the end of, well, not always, but typically sit on the end of pipelines. Head. Head gives you the first n lines, where n defaults to 10, either from the specified files, and you can change n. Actually, we'll make this a bit larger for these demos. And you can make it just give you the first, say, 3 lines. There we go. Tail is head's little friend. That gives you the last lines. Useful programs. Often you've got some data, or you look at the first lines in the file, the last lines of the file. Head and tail. What else? Now let's suppose I'm interested in just some subparts in the file. Cut. Cut can be used to pass through parts of each line. So grep we took lines in and passed a subset of them through. Cut passes all the lines through, but only part of each line. So I can specify this in a few ways. I can specify characters to pass through. So I can specify passing through characters 5 to 8. And we'll just pipe that to tail. And it's just got the course number. Cut also lets me specify fields. The default field separator is a tab, I believe. Don't worry about that. And again, let me remind you, it gets to the exam, yes, you may have to write things about cut and so on, but you'll have a cheat sheet giving you documentation, so you don't have to memorize everything. And also access to manual entries for most of the exam. So I can say, give me field 2 and the separator. Cut lets me say the separator is a pipe symbol. There we go. And that should give me all the Z IDs from the file. I've told it the line's broken up by pipe symbols. Field 1 is the course code, field 2 is the Z IDs. Oh, things went so badly. Why? Why? What does that message mean? That was a hypothetical question. I know the answer. But I'm glad you do too. All right, so pipe, what have we seen so far? Regular expressions, but that's not being interpreted as a regular expression. Cut doesn't interpret that as a regular expression. Oh, we could actually if it did, wouldn't it? Your Python programs would be thinking about split. Split takes a regular, so does Perl. That's really good. In fact, once you know Perl and Python, cut's not as good because it just wants a single character there, whereas specifying a regular expression is great. But what is the shell trying to do? Pipe means to it, run command on my left, run command on my right, connect stood in to connect stood out to stood in. So it's trying to run this bit. I should highlight that for people listening to this rather than. So it's trying to run that as a command and pipe it all to enrolments. So again, I've got to tell the shell, excuse me, that pipe, I don't mean a pipe. One possibility is single quotes, and double quotes would work there, as would a backslash, but one way or another I've got to do that. And then we get the Z. Oh, wait. So that person's taking 4 courses. Oh, interesting. The ZIDs there for. I wonder how many distinct ZIDs there are in the file. So in these enrolments, there is, we actually run this for the real enrolments file, which I can't show you because it's got a lot of private data in it. Unless there's someone here who wants me to put their WAM and all their other details up on the screen during the lecture. Maybe not. So this is the real enrolments file. Yes, it is. For this session. Oh, I lied, 9,730 students. All right, so let's see how do we find out how many distinct ZIDs? Here comes to our rescue another filter. Unique. Unique's actually pretty simple. It just looks for lines next to each other, and its base mode of behavior is to remove identical lines next to each other. He's thinking, oh, I could go home and code that up in C. I could. Yes, you could, and you should. It's a bit of fget, strucomp, away you go, you're right. Very easy to implement. So it seems like there are 3,791 unique ZIDs. But wait, that depends on all the ZIDs that are the same being next to each other. Is there any way that I can ensure, if I've got a list of strings, that the ones that are identical are next to each other? Sort. So unique almost always gets used with sort. As it turns out, this file, I think, was sorted already on ZID. It was. But almost always it's sort pipe unique. Put these things in order and then remove the identical ones. So we know there are, in this fake data, we'll run on the real data. Why not? In fact, let's link the real data in. I just have to be careful not to display it and breach student privacy. Oh, yeah, that'll do. So how many different students are taking a comp course this session? $4,706. No wonder all the labs are full. All right. Oh. How about who's taking the most comp courses? How many people are taking how many courses? He might be taking 1 course. She might be taking 3 courses. He's taking 7 courses, maybe. Unique has a couple of options. You're saying, Andrew, how can I find out what options Unique has? Count. There, look, -C, count. So let's try that out. We'll try it on the fake data so I can show it to you. All right, How do I find out who's taking most courses? You mean I can do 2 sorts in the one pipeline? Yes, that's my son. Well, he doesn't say it anymore. He used to say when he was about 9, YOLO. All right. If this goes badly, though, I'm blaming you. And there we go. How would I print just the person who's taking the most courses? There we go. So that's cut, pipe sort, pipe unique minus C, pipe sort, pipe tail. And we'll run that on the real enrollments and vaguely, I think that's okay. Find out someone who's taking a pilot. We'll see the ZID of someone who's taking a lot of courses. Is there someone really taking 5 comp courses this session? Yes, there is. All right, don't harass that person. Yes, you've got you. All right. One more thing with this data, then we'll move on to some other data. All right, so I want to know how many 2041 students I can do this. Look at that. Well, actually, or I could do this, alternation. Oh. No, wait, you're not real? Wait a minute, that's not the real data. We'll try the real data. Maybe. No. All right. Now, this is a mistake that maybe you won't make. I said grep comes in several incarnations. The version of grep you want to use, and which I accidentally typed, is egrep. Egrep has regular expressions just as I've described and similar to Python and Perl. It's to the core of Python and Perl. If you omit the E, you get a simplified regular expression language without a couple of things. If you're trying to run it on a tiny piece of hardware, you might like the simplified language, but these days that's not very likely. So how many 2041 students? What does that depend on, by the way? Let's look at the data. It seems like there's 510, but what does that depend on? What else is in the data? The person's name. So if Rebecca had been conceived, say, in a 2041 lecture, it would be a long time ago, wouldn't it? And her parents had made a middle name Comp 2041, then this would fall over. If you don't know who Bobby Tables is, Google Bobby Tables, not now, later. There's a cartoon, an XKCD cartoon about this topic. So what do I do to avoid this possibility? I'd actually do this. Because the course code is the first thing on the line, I could say that. Anchor the match. I have to put brackets there to say I want comp 2041 or comp 9041, like that. And that will give me these students. What about I want to know how many female comp 2041 students? The gender is there. I think UNSW has finally seen the light and no longer insists students supply a gender, but where they have, I think it's there. So I can do something like this, can't I? Say that, then followed by dot star F. Did that work though? All right, again, Actually, all right, I'll risk a little bit of invasion of student privacy. I don't want to show whams, but if I do the right cut and get it right, I can show names, I think. Let's try that. I think I've got that right. Ah, there we go. So these are oh. It doesn't seem like it's working. Some of these names are not looking like Zach. All right, I'm not. No, I can't do that. That will show Zach's wham, which is good, but I don't want to show it. What's gone wrong with my matching there? I've said that dot star F, and it's a common problem. Yeah, F, it's matching a string that's got a capital F anywhere. So it would match the F on Rebecca's family name. It might also match the F on a lab. So I think Zach doesn't have an F in his name, but he probably has an F in his lab, or maybe his plan. F anywhere. So we want to limit it to maybe the last one. And we can do that. All right, so that seems to do the job. Always a thing. When you're doing this sort of thing, am I matching too much, too little? Always do have some way of checking how your matching's going. Debugging code, some backup to check. Don't blindly assume something like this is working. No, that's the fake data. Definitely, these people are completely fictitious. Ooh. How would I find people? There's an interesting phenomenon here. This person has no given names. How would I find them? I think mainly the students we see in like this come from one part of Indonesia, I think. So how about like, there's two problems here. I want to search for the string comma space dot. Yeah. There's an error message. What's gone wrong there? Make me happy in the few seconds we have left together today. There's a special character there, an unusual special character causing problems. What's the special character causing the main problem here? Space, thank you. Space has a special meaning to the shell. It's used to separate arguments. Remember that. You'll meet that again and again with the shell. So I put quotes around that whole string. No longer any error message. But now we've got the issue of the dot having a special meaning in the regular expression, which we have to backslash.